Hello, welcome to another video of Digital Logic. In this video, we will try to convert a decimal number to a binary number. Okay, and here you can see that we have a decimal number that is 66, and the base is 10. That means it's a decimal number. Now, to convert a decimal number to a binary number, we have to divide it by 2. As you can see, this is our answer. So we have to divide it by 2. So if we'll divide it by 2, 66, that will be the 33, and the remainder will be 0. So we have to write the remainder here. Again we have to divide it by 2, and if we'll divide it by 2, then answer will be 16 and the remainder will be 1. Again we have to divide it by 2. So 16 divided by 2, that is 8. It means the remainder will be 0. Again we have to divide it by 2, then we will get it 4, and again the remainder will be 0. Okay, now again we have to divide it by 2, so it will be 2 and the remainder will be, again we have to divide it by 2, then the answer will be 1 and the remainder will be 0. And this one is the least significant digit, and you have to take it this one as well, and this one is the most significant digit, not this one. And some students forget to take this one, so remember you have to take this one as well. So the correct answer and the final output or the conversion result will be 100010. So if you will convert it 66 to binary number, the output will be this one. Okay, and in this number system you can see that it is the integer number, or it's not having any fraction point. So if one number will have the fraction point, so how I'll do that we will also discuss in our next video. Here you have to remember one point, that the conversion of decimal number to any other number system involve successive division by the radix. So in this case we want to convert this number to binary number system. So here the radix will be 2, or the base will be 2. So for that reason, if you want to convert a decimal to any other number system, then you have to divide by the radix, that is in this case 2, until the divided reaches to 0. At each division, the remainder gives a digit of the converted number, and the last one is the most significant digit. So in this case 1 is the most significant digit, and the remainder of the first division. So here the remainder is for the first division, it is the least significant digit. Okay, and the conversion of other number system to decimal number system involves multiplying each digit of number system with the weight of the positions in the power of radix and sum the products calculated. The total is the equivalent value in the decimal point. So we'll also discuss about this conversion also. We'll also discuss about that conversion as well. So thanks for watching this video. See you in the next one. Till then, take care. Bye bye.